Now when we have this and the better sound, I will start over to quickly explain you the previous videos and the previous steps of the workflow that I'm going to show you. And the previous step was defining the idea, shaping the idea with AI, with asking right questions and creating a discovery document, validating a prototype, and the new part is creating a technical decomposition that will help our AI to really do thing with the step-by-step document. So let's start. Okay, let's go. As promised, here is the whole thing. Now it's accessible through the website here. You can see that there are several phases. Let me quickly go through each. So the ideation, we have here a brainstorm, which is responsible for brainstorming a very high level ideas, uh, helping you to shape the high level thing. The product that helps you create the PRD documents and jobs to be done. This is more for product managers and those who want to act as a product manager. And the new feature. The new feature is a very important part. We can see here it contains of several steps. First, we ask AI to study the code base with the parallel agents. Then we do an optional research phase. I do my research using exa MCP and ref MCP all together, and it works very well. I can do a separate video about it. Research is optional. We force AI to research if we're not sure about scenarios, about the best solutions, new technologies, and so on. And then we do the interactive discovery, which is the most important part, the interview with the user. When AI with my idea in general that I provided to it in the very beginning with the code base context, with the research information, it started asking me questions, helping me to shape new features that I want to add. Then grill me, having all of this previous steps, it started to roast you about what you are going to build, to identify maybe something can be cut off. Then it writes a discovery spec, as since it follows the spec-driven development workflow, it's a very important thing. Our spec documents on each phase will be the source of truth for every AI working with it. And the cross AI validation step. That's also pretty much optional, but I use it. I want and love to use as much compute as possible since it's now pretty affordable. So I use Codex CLI, Gemini CLI, Cursor CLI. All of these skills are universal. You can see that we use it in other steps of workflow, and it's headless CLI's calls. So Claude reads the skill and do the headless call to the specific CLI, asking for the opinion. So, and the output here is a task file, the discovery file in a task folder. We also covered validating a prototype or visual prototyping, where when we have a new feature in a document, we can prototype it. We can see how it looks like visually, right? We also can validate if AI got us right. So this is important part. And today we're going to talk about creating a task. Creating a task is something that very important for the implementation phase. So when we have a discovery document, which is more about business and what we want to build, we have a prototype, then how we want it to look. It's not a direct instructions, but it's a general idea. And now we have everything to start with a technical decomposition. And the technical decomposition works pretty much the same. It studies the code base, and it's very important to always start with it. It studies the code base with a parallel agent execution. Then it creates the technical decomposition itself on the first step. Following the TDD approach, then we need to validate that our technical decomposition and implementation approach is valid. Is valid from the business perspective, is valid from the architectural perspective, and valid in general. So we have, for these purposes, we have plan reviewer, senior architectural reviewer, and CLIs as well, other CLIs, other compute. We do the parallel call for plan reviewer, which is mostly responsible for business and overall idea. The architectural reviewer, which is responsible for architectural approach, and the CLIs that can highlight things that Claude's model can miss. And in the very end of the step 2, we have the technical decomposition approved with all of these comments from all agents and CLIs, and all of these comments applied for as well. And the next very important step, I learned it hard way, is a task splitter. Task splitter is the agent that help us to split, obviously, the task to the phases, and it's important part. And even important how it's split. We really wanted to split it functionally, so the implementation follows the implementation logic. Task splitter also produced the phases and the task splitter evaluation document result, where we can estimate and whether approve or decline, or ask it to split it in a different way. If the splitting is approved, it calls another agent, which is task decomposer. It's specifically responsible for decomposition. It takes the decision from the task splitter agent, it takes the technical decomposition and do the job. I use a liner, so it creates both this nested folder in the task folder with the phase of the task and the liner issue associated with it. You can see here that the optional step is what I've just mentioned, is liner, and we can do like optional analysis. It's a specific thing, but maybe useful for analyze the whole thing one more time before we start. It's something that I use rarely, but it can help. The output file is a technical decomposition, the one that we throw to the next step. It's implementation phase to start the implementation, obviously. So let me now show you how all of this work and how all of this look when it's done. And one more thing to mention is in this website, you can not only see how it works, but also go to the source of this and see directly the skills, GitHub repo itself. So yeah, please enjoy. Let's also see how it looks when you open it in your IDE. This is a final result. We have the technical decomposition, the original one. This is a big one. You can see it's like about 500 or more than 500 lines. This is what we split. We have a splitting decision here. We have a splitting decision and the evaluation. We can, when we work with it, we can disagree, rework it, and so on. We have the discovery document here with more about the problem statement and questions asked. And we have here everything splitted, right? Every single phase and the liner issue. So the next step is the implementation. The implementation step will take us through each phase, and we will need to manually start each phase and manually review it. So on example, on one phase, I will show you the workflow end to end. And let me also show you how the technical decomposition looks through the perspective of cross AI validation. Oh, and this one, it was skipped. And it's okay. It means that we decided to skip the cross AI validation, not to put a lot of compute here. For this kind of demo tasks, it's totally fine. You can see there the review has an issue found. It's pretty transparent document that you can study. So let's see in the implementation phase. So what we have the ideation, the feature shaped, we have the visual prototype, we have a technical decomposition, and the next step will be, as said, the implementation phase. So see you in the video with implementation and both code review phases, where we will see how it works end to end. Thank you for watching.